Hello students, how are you all? Welcome back to Akshar IT Foundation classes, class 7, chemistry. I am your chemistry faculty, S. Mohan. So students, in the previous class, we completed the atomic structure synopsis 5, right? So today, we are going to discuss about the synopsis 6. So students, in the synopsis, what we are going to discuss are atomic number and mass number. A small topic, this is just atomic number and mass number. Okay, so see now, first one is atomic number. So students, in the previous class, already we discussed in the previous classes that atom consists of electrons, protons and neutrons. We also discussed that electrons are discovered by the J. Thomson, protons by Rutherford and Goldstein, and neutrons by Chadwick, right? So, atom consists of three particles, electrons, protons and neutrons. Okay, and in that we also discussed that protons and neutrons are present in the nucleus, electrons will be revolving around the nucleus, right? And generally atom is neutral because the number of protons present in the nucleus are equal to number of electrons revolving around the nucleus. This is all we already completed. Now today we are going to discuss about the atomic number. So students, atomic number is nothing but the number of protons present in the nucleus. What is the atomic number? The number of protons present in the nucleus. So number of protons present in the nucleus is called the atomic number. Okay, and atomic number is denoted by the letter Z. Which letter we use? Z. So Z, we use the letter to represent the atomic number. Okay, so in a neutral atom, just now it said that in a neutral atom, number of protons is equal to number of electrons. Yes, so the meaning is what? Atomic number is also equal to number of electrons, is also equal to number of electrons. So a atomic number means what? Number of protons which are also equal to number of electrons, okay, in a neutral atom. That's about the atomic number. Now, what is the mass number? Students, what's the mass number? Mass number is nothing but a sum of the protons and neutrons. What's the mass number? Sum of the, what is the sum? Addition. So, sum of the protons and neutrons means what? Number of protons plus neutrons, okay, combinedly is called mass number. So, sum of the protons and neutrons is called mass numbers. Means what? Number of protons plus number of neutrons is called mass number. So, here students, number of protons is denoted by atomic number. I said it's also known as atomic number denoted by Z. So, I can write the proton, number of protons I can write as plus number of neutrons denoted by N, which is equal to atomic number, and atomic number is represented by A. Atomic number is represented by A. A is equal to Z plus N. What is Z? Atomic number. N, number of neutrons. So, A is equal to Z plus N. If we want to find sometimes N, okay, if we want to find N, number of neutrons, then Z, bring this side, it becomes A minus Z. A minus Z. So, this is the formula to find the number of protons, number of neutrons in an atom. Clear to you? So, atomic number means number of protons. Mass number, sum of the protons plus neutrons. So, this is about the atomic number and mass number. Clear? Now, if you have a material, once you see the page number 159, there 1 to 20 elements, okay, that is hydrogen to calcium. Already students, you learned about the elements, their symbols, atomic number, mass numbers, okay. Now, let us see here. So, now, first let us see how the atom can be represented. How the atom can be represented. Generally, atom can be represented in short like this, okay. So, here they can write now X, okay, and here the subscript they write A, and on the superscript they write the Z. So, this is the representation of atom. Generally, elements can be represented in this way. So, X at the top means as a superscript A, and at the subscript is Z. So what it represents? It represents that here X, what is there? X is the symbol of element. X is what? A symbol of element, right? Now, what is A? A is equal to, already written there, mass number. Then what is Z? Z is equal to atomic number. Atomic number. So, this are the, okay, this is a representation of a element in short. Clear, students? So, here if we know, generally most of the elements will be represented like this, and if we know the mass number and atomic number, then we can find easily about the number of protons, electrons and neutrons. Okay. For example, if you see in a material, okay, if you see in a material, there's a chart is given, right? There's a chart is given in which 1 to 20 elements, okay, that is hydrogen to helium are given. So, if you see the first element, then symbol, atomic number and mass number. So, by using this atomic number, mass number, you can write how many protons are there, how many electrons are there, how many neutrons are there, right? Now, I'll explain you how to write the electrons, protons and the neutrons. Okay, students. So, see now here you see here, I'll take few elements. So, for example, I'll take hydrogen. Okay. So, hydrogen is represented like this. Okay, 1 and 1. So, what is the meaning of this one is H. H represents element, hydrogen. Element is what here? Hydrogen. Okay, element is hydrogen. And what is its atomic number? So, first we write the mass number. So, mass number is what? So, see, mass number is represented by A. Mass number is represented by A. Where A is written? A is written as a superscript. So, here what is the superscript? 1. So, mass number of hydrogen is 1. And what is the atomic number? Atomic number. Atomic number means what? Z. Z is represented as a subscript, means down. Here what is the down number? 1. So, atomic number is also 1. Now, let us see here, hydrogen consists of how many electrons, how many protons and how many neutrons. So, see students here now, protons, electrons and neutrons. Okay. So, first we write the electrons, no problem, anything you can write. Protons, electrons and neutrons, right? So, electrons. Electrons is nothing but a, see, I already told you that number of protons in an atom is also equal to number of electrons, correct? Number of protons is also equal to number of electrons. So, if the atomic number is 1, the number of electrons also 1. If the atomic number is 1, proton is also 1. Now, I want the neutrons. So, what is the formula for neutrons? Neutrons is equal to A minus Z. A is what? Mass number. Z is what? Atomic number. So, A is mass number and Z is atomic number. Mass number minus atomic number gives a number of neutrons. So, 1 minus 1. What is the 1 minus 1? 0. So, there are no neutrons in the hydrogen. There are no neutrons in the hydrogen. So, hydrogen is the only element in the periodic table, students. Remember that, without a neutron. Okay. And one more important thing is that there are isotopes of hydrogen are there. In that isotopes, again, neutron is present. That I will discuss immediately after this topic. Right. Okay. Now, so similarly, for example, I'll take some other element like carbon. Okay. So, carbon. So, carbon is represented like this. So, here C. C is the symbol of what? Carbon. Okay. And A means what? Mass number. Here superscript is what? 12. So, mass number is 12. Z is what? Atomic number. Here subscript is what? Atomic number. So, 6. Okay. Number of electrons? 6 only. Atomic number is equal to number of electrons, which is also equal to number of protons. Now, I want number of neutrons. Number of neutrons formula is what? A minus Z. A is 12, Z is 6. 12 minus 6 is equal to 6. Okay. There are 6 neutrons are there in the carbon. So, 6 protons, 6 electrons, 6 neutrons. Clear? Okay. One more let us see. Let us take the sodium. Okay. Na with atomic number, mass number 23, atomic number 11. Okay. So here the Na is what? Sodium. Na is what? Sodium. Now mass number. Mass number is what? 23 here. Okay, 23. What is atomic number? 11. Okay. How many electrons? Atomic number is equal to number of electrons. So 11 only. How many protons? Which is equal to same. So 11. Now number of neutrons I want. Number of neutrons how many? 23 minus 11. So 12. Okay. So like this, in any atom, we know the atomic number and its mass number. So we can find what is it, what are the number of electrons, protons and neutrons in that particular atom. Clear, students? So today's your work is okay. So see the table, and of course you know, I think the first 20 elements, atomic number, mass number. If you don't know, then first you read the elements 1 to 20, hydrogen to calcium, then their atomic number and their mass numbers, right? And then by using this atomic number, mass number, then write the how many protons, how many electrons and how many neutrons are present in each atom. Clear? So you can see in the page number 160, 161, that same number is given. How many electrons, how many protons, how many neutrons are present in an atom. Clear? So now then come to today's the most important topic is what? Isotopes, isobars and isotones. What are the next topic, students? Isotopes, isobar and isotones. First you see isotopes. Okay, isotopes. And the second one is isobars. And third one is isotones. Okay, so here isotopes, isobars and isotones. What are isotopes? Students, isotopes definition is what? The elements with the same atomic number but a different mass number. Means what? Atoms of same element with the same atomic number but different mass number. So see, students, here hydrogen is available in 3 forms. Okay, so hydrogen is available in 3 forms in the nature. Okay, if you see all the hydrogen's atomic number is 1 only, 1. Okay, but mass numbers if you see 1, 2, 3. Okay, so here if you see 1, 1, 1. So these are what is subscript. Subscripts are what is Z, means what? Atomic number. Atomic numbers are same but mass numbers are different, right? So such elements are called isotopes. Isotopes means what? Atoms of same element with the same atomic number but different mass number. So atoms of same element, all are hydrogens only, with the same atomic number but different mass numbers. Mass numbers are different. So they are called isotopes. Okay. Now isobar, exactly opposite definition to this one. So what are isotopes? I said atoms of same element with the same atomic number but different mass number. Just to write it down. Atoms of different element with a different atomic number but same mass number. Means, for example, if you take carbon will be available in 2 forms. Okay, so otherwise we can take argon. Okay, argon and calcium. We take the argon and calcium. Argon atomic number is 18. You know that. Argon atomic number is what? 18. And calcium atomic number is 20. But if you see their mass numbers, both the mass numbers are 40. So these are 2 different atoms, right? This is argon, this is calcium, 2 different atoms with a different atomic number but same mass number. They are called isobars. If you compare here, both are exactly opposites here. Atoms of same element, atoms of different elements. Same atomic number, different mass, different atomic number. Different mass numbers, same mass number. Okay, right. Now come to the isotones. Isotones means, students, atoms of different elements with a different atomic number, different mass number. All are different. Okay, but same number of neutrons. Are called isobars.